Hi everybody, so here's a familiar face. This is a Carver model C19 and we did a video on this one. This is the one where I actually had my nephew 3D print a set of connectors for the rear, which is this back here. You can go back and look at the video. But it came back here on the bench because it has got a very interesting problem. And this is something I've never seen before. I don't know. So let's turn it on. And it's intermittent. Sometimes it does it really badly, sometimes it doesn't do it. It's intermittent, but it will eventually do it if you wait long enough. And I have a MP3 player connected just for some music, and it's probably copyrighted stuff, so I gotta watch that. But if you remember, this thing has some vacuum tubes in it, and there, you can hear it. You hear that sound? And when we tap on it, it is actually microphonic. So you would think that the problem is that the vacuum tubes have gone microphonic. Problem is, if you listen, you still have that sound. But I don't have the tubes in there. Yes, it is microphonic even without the tubes. The tubes are microphonic sitting on top of it. And I've never seen anything like this before. It's very bizarre. So I guess the thing to do now is try to figure out why. Now I'm taking the microphone off again. And you hear those little pops? And they're randomly between the right and left channel. So here's left channel, right channel, and again, we still have no tubes in there. Now, obviously this is a open circuit, but you could see just moving my finger, super duper sensitive. It's like something in here, like we're losing a ground or something somewhere in here on the circuit board. Very strange, and it seems to do it intermittently. So like if you turn this off, you wait a little bit and you turn it back on, you notice nothing happens, and then after about a minute it'll start to do it again. And it doesn't care if the tubes are in it or not in it, it'll just do it. So you can see now there is no noise. The amplifier is turned on. As soon as I turn the volume control up and then back down, it comes back. Very, very strange. So I think we need to do a little bit of digging here, don't you? So looking at the underbelly, this is the first thing that kind of jumped out at me, which is right here. If you look right in here, these look to be, I don't know if this is a multi-layered board or if these tracks are supposed to be tied together, but you can see this one here is eaten right away. There's nothing here. This one is completely almost not soldered. This one's all right here. And if we flip this over, and let me see if I can do this without moving the camera. We'll see where we are. It is actually right here that we're looking at. And let's see if I can get you moved over. And you can see it's right in here. And this is a 10-volt Zener diode and a resistor. And if I recall correctly, I think these components were burned up. And I think one of the other things that these C19s have a propensity to do is that the voltage regulators run really hot on these, and that's why you see this. I put a larger heatsink. I remember this now, I think. And I think these were burned up. And it looks like that's what happened here again, is this just these traces are just bad. So we have to kind of look at the schematics a little bit, which we have right here. And we have to try to see. There's D23, which is your 10 volt Zener, and it's right there on your plus 10 volt bus. R513 is a 220 ohm resistor. And then they connect together on the U14A, which is a 4558. And U14 just so happens to be this little chip here. And you notice it kind of looks a little bit scorched as well. So we may luck out, and that may be where all the problem is right in here. But let's get a meter on here and see if we can see what kind of voltage we have. All right, we're clamped on here. Let's turn it on. We're just looking right across that Zener diode. We should see 10 volts there, right? And I'm not seeing any volts. Am I? Oh. Take two. It helps to plug it in. The electrons have a hard time jumping from the outlet to the prongs of the plug. So let us plug it in and try once again. 9.7, that's a little bit low. .8, it's going up. Okay. That shouldn't, I wouldn't expect that to do that, but perhaps as the tubes warm up, now it's up to 10 volts. Strange. So let's plug this back into the output. Turn this up. Yep, and it's making the noise now. And that voltage is slowly climbing up. And as you can hear, very, very microphonic. That's kind of settled down now. Well, maybe not. No, it isn't. It's still going up. So something is shorting out, or is at least has a lot of leakage that's causing excessive current leakage. I wonder, of course this thing worked before, I wonder if maybe there's a capacitor that got put in backwards or something. So next thing we'll do, let's unplug it, because it's just going up and up and up. And let's just touch these capacitors. If one of them is in backwards, it will be very, very warm when you touch it. And I'm not feeling any warm capacitors. They're all ice cold. Nope. Absolutely not. So we're not having a problem with the capacitor. So now, how about these little transistors? They don't seem to be doing anything. Both channels, but these would be for either channel, I would think, and I'd say that both channels are doing the same thing. So it has to be something common to both channels, or you wouldn't be hearing that same problem on both channels. So something in here is not happy. And it seems to be right in this area where it's getting ultra sensitive. So I wonder if maybe one of these op amps or something. But of course, again, why? Let's see. Okay, another thing I think I found is when I grab this, just moving this socket around makes the problem go away sometimes. Now it's gone, see? I think we have a bad solder joint or a bad socket in here somewhere. Well, I soldered these up. It worked for a few songs and yep, it's back again. I have no idea what this is. So, I don't know, back to the drawing board. Well, there was nothing left. It had to be those two chips, so I removed them and put a couple of brand new TLO 72s, just like what was in there, and very disrespectfully and unceremoniously clipped them out. These boards are extremely hard to solder on. They're those kinds that if you're not really careful, you'll break the tracks right off. But anyway, it's working now, and I mean, it works perfect now. So I think that's all it was, and that was a weird problem. And I think actually that it was this one here, this U11, that was the bad one, but I did replace both of them. Okay, so just for a quick review here, you have these two coming right off of the plate, these two op amps. They're TLO 72s, and it's U9, and that's for those control the first stage, right and left channel, and then there's U12, and they control the second stage there. Hope I'm on camera. And I believe it was U12 that was causing the problems. I didn't really sit and really study this circuit because, of course, with Carver you have all these strange circuit design features that they put in there, and you really have to kind of, if you're not a trained Carver service station, you really have to look at these schematics and kind of figure out what they're doing. But this very dramatically will affect the whole sound in this loop here on both sides, you know, in this stage and in this stage. And I think one of these op amps was failing, which was causing, you can see you have the inverting input coming off of the plate of this, what is it, the 6DJ8, and then it comes back and feeds back into the cathode. So you can see how it could affect the gain of the whole circuit, and if it goes crazy or it outputs a voltage that it shouldn't, you can see how this whole circuit could just, you know, go out of control. And you can see the noise path even with this tube removed. This is why it was doing it, because if we remove this op amp could still output a signal, noise or whatever, and get into the next stage, and that's what was happening. So I think just replacing this fixed it. And again, you know, Carver, these are, everything that Carver builds seems to be kind of different. It has its own little design, which is cool because, you know, everybody makes the same circuit the same way, and they try to differentiate themselves by using better quality components or something. But these guys at least tried to do something different by trying a circuit design that nobody else tried before. Sometimes it worked, in my opinion. Sometimes didn't always work as well, maybe. But nevertheless, it's very interesting to work on. So I think that's all that was wrong, and I've been playing this for a while now, and it sounds really good. It works, and I'm going to button this up, and we're going to call it a day. So that's it. I'm going to do some tests on it. If it continues to work okay, then we're going to button it up, and we're going to call this one quits. So that was a pretty quick, easy troubleshoot, and we're going to get this one off the bench. So in the meantime, I wish you all peace, joy, happiness, and good health in your lives. And I want to thank you all for all the wonderful comments. I really need to do a video just to kind of thank everybody and catch up with all the comments and questions and things. Maybe I'll do one of those when I get a chance here. But just know that I'm reading your emails, I'm reading your comments, and I really appreciate everything. So until then, take care, and we'll see you all real soon. Bye-bye.